talk about myself. So I have a BE, MTech and a PhD in communication. So I completed my education, all of them in erstwhile KREC Surathkal, now it's called as NITK Surathkal. It's one of the premier government institutions in the country, but all my schooling was in a government school, trust me with that. So life was really not very easy. So we used to have rain pouring from the top, and the floor used to be flooded with water. So we sat in all those kinds of classrooms, and so it was a kind of a very, very different life from what life is altogether. And I graduated in 89, my BE, my master's in 91. So I've been working since 1991. So that's about 31 years of my career. So I come from the time that we had to wait 2 years for a landline. So you can't even dream of it, right? You can walk across the street and go buy your phone with your Aadhaar card or whatever ID card. So I end up teaching 5G and telecommunication and how 5G works, and most of the time I teach actually maths, business statistics and maths to go with all of these things. So that's one of the reasons why I'm here. So today we will see simple maths. Okay, I'm not going to do any sums or whatever it is, we'll make you do something. So it's all based on what you learned in school. It doesn't need anything extra. Why we emphasize so much on mathematics? Why is it required? You're all BCom students, right? BBA students, okay. BCom and BBA all mixed. Very good. So some maths you would be studying now, and you would have also studied in your school days. So we'll just see how much of it you remember, and so people are already smiling, oh my god, I can't remember anything, what is this woman going to do? No, nothing like that is going to happen. So we will see simple math. We'll try to understand how people use math in business scenarios. We'll do just applications which you can relate to. Okay, I'm not going to do any sums with some formulae or something like that. So we'll see how it also helps. We think mathematics for decision making. As simple as it is, if you're looking at just plain numbers for decision making, the simplest that you can think of is the cost of a product, right? Just numbers. What's the decision you make? Do I buy this? Do I not buy this? Simplest decision. Yes, no? Isn't it? It's just numbers. So if you are looking at the business scenario, or running a company, or you working for an organization, you may have to do a whole lot of decisions, as we say. And sometimes you may also think that decisions may have been wrong decisions, right? But you would have already done it, and there is no looking back. Yes, no? So many times it could be the smallest thing, like buying a dress maybe. And once you buy and put the dress into the water, the entire color is gone. You're like, oh wow, why did I even go buy this? Have you not felt that? Very small things. But there isn't anything like, it's already done, right? You've already made that decision. So if something you think is wrong, are there ways of setting things right? We're not going to talk about that now. But decision making also involves that if you have already made this decision, then what do you do? If things are not okay, that is food for thought. You can think about it at a later point of time. So, question was, I was asking you, right, how many math classes or whatever subjects you have studied? You're all in the first year now, right? So, which means in pre-university, 1 to whatever, 12th and 11th, one subject each you would have studied with multiple topics. Linear algebra, calculus, blah, blah, blah. No? In your first PU and second PU? In commerce, you don't study all of those things. Linear algebra, probability and all of those things you don't study. You haven't studied any of those things. Matrices you studied in high school? So high school you did matrices. You've forgotten or what? People say school education, we don't forget. College education, we forget. You've forgotten school also. You haven't done matrices? No? You haven't done it, right? 10th standard they used to have no matrices.
What time we had 10th standard matrices? They have. I am using CBSE 10th standard syllabus only.
Yeah. So you have studied matrices. It's okay if you go back and see you've done matrices in 10th standard. Alright. So what according to you is decision making? Very quickly, this just starts reducing our time. Now we have only 35 minutes and I have to compress the talk. So what according to you is decision making?
Decision making is the process of making choices by identifying the decisions and gathering the information and adopting the alternative direction.
Very good, excellent. So you've given a proper definition of decision making. So you have a lot of criteria and you weigh the odds, right? What works, what doesn't work, and then you're making whatever informed choices, I would say, right? So making informed choices. So what exactly are we looking at in today's session? So we are saying mathematics for decision making in your context. I'm trying to say BCom and BBA, whatever it is. So we are trying to see how well you can understand business processes, what you can do with regards to your organization where you work, or you start, you're an entrepreneur, or you're consulting for somebody. So it's related to business processes. We're also looking at creating mathematical models. Not all the problems that we think of are very easy to solve. They're just not simple numbers. You have number crunching, but how do you crunch these numbers? From where you get these numbers? What do you do? How do you validate the data? Who said the data that you got is right? You don't know, right? Somebody gives you some data, like we are saying make informed choices, but from where did you get the data? How do you even validate these data sets? So we need to create models for these processes. You have to validate the data. You make decisions and then you have to implement these decisions. That's where the problem is, right? So how do you take forward these decisions? So they're saying mathematics for decision making should enable you to do all of these things when you start doing this. So what mathematics does for you is to simplify a lot of these things. Whatever you have, the data that you have, how do you make these choices? It helps you to create a model for you to make your decisions. And also, let's say you have created a model, can you adapt this to suit other requirements? So it makes a little simpler for you to adapt these data sets or models to do other jobs. So this is what I was asking. So x plus y is to quickly go back. Now I want to solve all of these things very quickly. Simple math it is. So it is 4 o'clock now, 4, 5, I want to see some answers coming out. Sum of two numbers is 2, product of the same two numbers is 3, like I said x plus y is 2, x y is 3. Find sum of the reciprocal, that is 1 over x plus 1 over y, that is what I want to find. Then the next one, so I have two numbers, root of 6 plus root of 10. You don't need calculators, if you have calculators don't use them. Okay, don't use calculators. I want you to solve them without calculators. So, which number is greater? Root of 6 plus root of 10 or root of 5 plus square root of 12. And find the sum of numbers from 1 to 99 without using you have a standard formula, right? Total of a series. Yes? Sum of a series, arithmetic progression. Yes, no? If you don't remember, I'm very happy because I don't want you to use that formula. So don't use the formula. Please do this. Now you have two squares there, right? That is a square, okay, inscribed in a circle. That is again inscribed in a square. So I want you to find the ratios of the areas of the two squares. 5 minutes time, quickly. Let's see. Guys and girls, you must try to make the decision of not to do something. That doesn't work. Make the decision of trying. They're very simple actually. When I show you the answers, you'll realize, oh, yes. Solutions are very, very simple. I see that you people are looking at very, very complex solutions. They are not. They're very, very simple solutions. Yeah, high school math. Okay. I think you're all going in the wrong direction. Let me start giving you some hints. Look at the first one. Sum of two numbers is 2, product of the same numbers is 3. Find the sum of the reciprocal. So 1 over x plus 1 over y. Correct? Yes? If you find the common denominator, that is xy, numerator becomes x plus y. Correct? So what you have to do is just 2 by 3, right? Yes, no? I saw people solving linear equations. No, not required. Look at the next one. Which number is greater? How will you do this? People are trying to find out square roots. How did you find out? Okay. Check. That is logic. Good. We'll see whether it's correct or not. How do you actually solve the next one? You square both of them. Square them. A plus b whole squared. A squared plus b squared plus 2ab. Okay? So you will see, you will get terms which will actually cancel out and you can simplify and see which number is greater than the other. Very simple it is. You don't have to find the square root. Actually, you don't have to find the square root. Look at the next one. Find the sum of numbers from 1 to 99 without using the standard formula. 1 to 99, you need to add them. 1 plus 99 is 100. 2 plus 98 is 100. 3 plus 97 is 100. 4 plus, makes sense? Simple, right? Yes, no? What about the next one? A square is inscribed in a circle that is inscribed in a square. Find the ratios of the areas of the two squares. It seems very, very complicated. But it isn't. If you just try, I have the answer. Look at the last one. You can actually get the diameter. Yes, no? The side of the square. Can you see? This is how it is pictured. It is given to you. All you have to do is to just turn it around. Can you see? This is how it is. Got it? Yes, no? You can actually finish them later. Half, right? Yeah, you get half. Okay. So anyway, that was just to see, how you look at math. Was it very complex for you, those sums? No? Yes? Solutions were very simple, right? But what decision you made, you assumed that the sums are very complex and you looked at solving them in whatever complicated manner. So most of the solutions are pretty simple. So read and understand the questions better, right? So I don't have time, otherwise I would have sat and explained more of these sums, but just saying. So look at a standard example that we would like to see for a business. I'm just trying to bring in that math into the decision making. Why do we need math? So we have, most of you haven't studied probability, that's what you said, right? Yes or no? You don't know probability.
In times probability.
Little bit of probability in 10 standard. You all know it must be less than 1. That much you know? No? No. I don't want to get into it. So if you don't know, it's okay. I'm just asking. So let's assume nobody knows probability. So when we are saying probability, what is the meaning? It is a chance, right? So when I say the sun rises in the east, always true, right? Isn't it? Probability is 1. The sun rises in the west, probability is 0, doesn't happen, right? These are known facts for us, so I am just giving you an example. So it is the possibility of occurrence of an event in very, very simple terms. So somebody gave that answer. So we are saying here, just to bring in that math into a decision making, that's the context, right? So if you are looking at somebody who wants to open a store somewhere, forget about those townships or names. So we are saying that they need to make two decisions. A decision of opening either in San Francisco or in New York. So they have probability of success given to us, probability of failure. Obviously it is 1 minus that or 100 minus that, that is the probability of failure if you know the probability of success. And we also have some investments that are made to open these shops. This is what is given to us. So we need to make a decision of where we are actually going to open this store. So how is this done? I am not taking you to the entire process, but just explain. So this is how this is called as a decision making tree. So how decision making is done. Again, we have a couple of formulae, very simple. I'll explain and I'll tell you what it is. That's the reason for doing that math, whatever we did, how simple it is. So we have now, if you just go back to this and see, we want to invest 2 million in San Francisco and 5 million in New York. Right? So that's what we are saying here. So 2 million in San Francisco, New York is 5 million. And then we have some payoffs. So whatever you are able to make out of opening that particular business. So if we make these calculations, so we are going to define what is called as an expected value. So what is this expected value? When you go and write an exam, somebody asks you, how much will you get? Yes or no? Then what will you do? You will actually sit and calculate, right? I hope that this sum is right, so therefore I'll get so much marks. So there are two things now. One is what is the mark assigned to that question. The other is the probability that you will get that sum right. Are you getting what I'm saying? So if you get it right, you get the full score. If you get it half right, you get some marks for it for the steps that you have written, isn't it? If you get it fully wrong, you get 0 for that particular sum. Are you following what I'm saying? So there are 3 things which will happen. So that middle percentage is there, where it would be based on how many steps you got right, will give you some part of the marks. Clear? That's what we are trying to do here. Expected value, that is what you think you will get out of your exam, is a probabilistic term. It is probabilistic, right? If you don't do all the sums right, you don't know how much you are going to get, or if you have missed some steps, you may not actually end up getting some marks. We call that as an expected value. That is the one which tells us what is the outcome of the scenario. Here, what is the outcome of our scenario? Where are you trying to open that store? And it is dependent on the probability of success, probability of failure. So we are trying to now find out, like we ask you how much you are going to get in your final exam, we are trying to find out what is the expected value. So we will try to calculate that. So what it tells us is whether it is worthy enough to invest in that particular business or not, in very, very simple terms. So when you do that particular calculation, this is how it is going to work out. So what is that expected value? Like I said, it's the score that you are trying to get, but we are trying to work a score based on the probability of success or failure for opening a store in a particular place. So we say probability of A and probability of B. That is what you are trying to say, right? Whether half your sum is right or your sum is fully right. So what percentage of it is right? I'm bringing it down to very, very simple way of explaining because you are not familiar with probability, and this I was not aware of. So I have to just add value to what you already know. So here we have 2 outcomes, right? Success or failure. That is, people pass the exam or they flunk the exam. 2 things. Some similar to that. So either you open the business or you don't open the business. You open, you make money or you don't make money, right? So that is, you have 2 outcomes, success or failure. So we have the probability of representing whether it's going to be a success or a failure. So I have these numbers. Yeah. So you can see here for San Francisco, we had 0.4 was the probability of success and 0.6 was the probability of failure. And similarly, we had some payoffs, whatever some numbers were there. So based on that, when you do that particular calculation, you end up with numbers. So we have mathematics which gives us these numbers. What is the probability of you having this business making money or not? So it's very important for us to get these numbers. Then you calculate, and again it is decision making. What decision you do, whether you want to open the store or you don't want to open the store. So you see here, in also you have invested some money, right? There is an initial investment if you recollect in the first slide. So there is an initial investment. So how much money you make minus that investment, is it worthwhile opening that particular business? So you see, it's not worthwhile opening the business in New York because you end up losing $300,000. So just to understand how you are able to use probability to decide whether you want to open a store or not. So in decision making, there are different ways in which we make these decisions. One is certainty. You know all the factors. You know this will happen, this will not happen, so you make your decisions based on that. The other is under complete uncertainty on the other side. Some part of it is a risky business. You don't know whether it will work or not. So we have three different categories where we make our decisions based on the information that you already have. So we create what is called as a decision matrix. It may seem a little irrelevant to you. I'm going to skip some of these things only for the fact that I was not aware you people didn't know probability. But I'll explain in whatever simple terms that. You know equations of straight lines, y is equal to mx plus c? Known, right? Correct? Yes, m is the slope and c is the intercept. Known to you? All of you know equation to a straight line? So if you have multiple points, you can put a straight line. Yes, it will cut the y-axis, that is called as the intercept c, correct? Then the slope of the line. Clear, isn't it? So a simple example for that to understand is, let's say you want to buy a house in a particular locality, and I plot area of the house on the x-axis, cost on the y-axis. Okay. So as area increases, cost increases, right? So it's going to be a straight line. Is this making sense to all of you? It's a straight line. And anywhere in between, if you just mark a point, you can bring it down, you will find the area of the house, take it on the y-axis, you will get the cost of the house. Correct? Yes? Yeah, so we'll just look at a very simple example here, again related to business, how you can make decisions. What kind of decisions you can make? Simple linear equation for a straight line. So we have a factory which is producing two products, X and Y. So we want to understand how can we maximize the profit. So by that what we mean is, so let's say a company is selling two phones, whatever, OnePlus and Xiaomi or Samsung or whatever. So two brands of phones. They want to make a decision of which phone I must sell more to make a profit. Are you getting what I'm saying? So let's say your decision would be that whichever fetches you more money, you have to sell that. But it also works on volumes, right? How many you are going to sell, it's just not the cost. Also, this shop vendor would have procured the phones from somewhere, which means he is also paid for it, right? So there is a margin also. You know margin, right? They will buy at 100 rupees, but they will sell at 110. So what is the margin for this person as well? So it's not a very, very simple thing to make a decision of I sell 20 of whatever, some phone and then 25 of another phone, so I make the profit. It's not going to be as simple as that. So that's what we are trying to understand in this example. So we have a factory which is producing two products, X and Y, and whatever. So there is some profit per product. So we want to understand how much of each one you need to make for this particular company to earn profit. So you will see these are the different lines that you would be able to draw. Again, I am not going to the details. So different combinations if you put. So you will see that these are the different lines that you will be able to get. So now the question is, what are the other information part you want to include in this to make a decision of how many of X I must sell and how many of Y I must sell. So these become the restrictions. Are you all getting? Yes? It could be how can I buy them and sell them? How many people I need to make X? How many people I need to make Y? Can I really make these things? So these are called as the constraints. Are you all getting what I'm saying? I have two products, I want to sell them and I want to make the best profit, but I have some restrictions. So it appears as if you can do any of these things to sell your product, but then I need to see what are my limitations or what are the constraints. So that's what we are going to see next. So what are the constraints now? For want of time, I am not really explaining, but let's just understand. So if you want to sell 3 of X and 2 of Y, then the machining time becomes a constraint. I need 120 hours of machining time. If I want to sell 1 of X and 2 of Y, I need 80 hours of whatever, assembly line, machining time, whatever. So these are now the restrictions. So I don't have enough machines, maybe I don't have enough people. So I can't make so many of X and so many of Y that I need to earn. So when you put these constraints, so I put that, right, so 3x plus 2y, whatever, you can actually plot the graph. So with all those lines you saw, all the linear equations, you had so many lines, right? You can't fit all the lines to earn a profit because you have restrictions. So the math helps you to understand. You use your y equal to mx plus c to draw all of these lines. Then you put constraints saying that you can't do this, you can't do this, therefore you can't make so many products. So you see that with this you will be able to get only that particular unit, you will be able to earn a profit. So this is how you make decisions. And then the decision making was, you have all the information, it is very certain, right? Decision making under certainty. Now if you want to make decision under risk. So one simple example again. So let's say you want to dig a borewell. Okay. What can happen? Either you get water or you don't get water. Two things. Okay. Sorry? Yes? Yeah, please. Yes, absolutely, correct. Yes. So I mean that's the only thing, right? Either you get water or you don't get water. Only two things can happen. Or you get water, but you need to dig very deep, right? Yes, no. So you need to decide how far, and so the cost starts becoming higher and higher. Are you with me for this? Yes. Now you have two options or whatever, multiple options. You need to ask somebody to drill that hole. So what happens now? Let's say you already have a boring machine. So you know, and you have somebody who will get their boring machine, invest, and maybe you want to use that for some profit making business. So that guy who comes will say, I will invest, I will dig this well, I'll get the water, I'll make profit from it, and then I'll also give you the money. Are you getting the different scenarios? So how do you make the decision now? Do you give this opportunity to that guy who will do this boring, get the water and also run the business and also give you profit for doing that? So this becomes decision making under risk, because you don't know first of all whether you'll get water or not. Next is, this person should do something with your water, get money, and then also pay you for that. So this is decision making under risk. So we use the similar formula of expected value that we calculated, right? There is a probability, there is some cost that is involved, you multiply the two, you add, you subtract based on whether you are making profit, you are making losses. So you don't drill, no money for anything, you just don't drill, no water, nothing. So it's all zero. Next is, you drill, you are not giving it to some outsider to run the business or make money from it or anything like that. So that is the second row. The last one is, you rent it out to somebody, that person will dig, get water, also make money from it and also give you the money. So So we decide now, first one is anyway ruled out, so you calculate for the last two and then you make your decision, what is it that you actually want to do. So then the last one is decision making under uncertainty. So in this uncertainty, so again, you don't know what is going to happen. Right? Everything is uncertain. So you decide whether you want to do it. It could also be that this borewell guy is digging and then all of a sudden there is heavy rainfall, whatever it is, and his machine itself collapses. Totally uncertain. So we don't know anything about it. So the way we calculate this is also going to be very, very different. So we have three categories: certainty, risk-based and uncertain concept. So I am again not going into this part of it. One understanding that we need to have is what is called as regret analysis. What is that? Oh no, I should have attempted this question. I did the wrong question. I ended up getting 0 marks. So many times, right? Regret. You can't look back. It's already done, right? So we have what is called as, again, regret analysis. So what this tells us is, so here in businesses, you can do it before the event happens. That is, you do a regret analysis to understand what if we did this, what if we didn't do this, what is going to happen. So that is called as regret analysis. And you can decide whether you want to minimize the regret in itself. By minimizing regret, we are trying to say you reduce that loss margin or something like that. So that is called as regret analysis, and they are all in the same context. So we have another very interesting branch of mathematics called as game theory. Have you all heard of it? Anybody who knows what it is? They don't read that definition. What is it that you have understood as game theory? Very interesting it is. I'm not doing any math, but I'm just going to explain and tell you. Very important for business decision making actually. Anybody, very quickly. Where have you heard of it?
Probability, like theoretical distribution.
This time now you're being from?
12th.
PU, okay, 12th standard. So, okay. What actually happens in a game? Can anybody tell me? Forget about this math and all this is mind-boggling. What happens in a game? It's exactly the same thing. Sorry? Yeah? Okay. So, little next to that. What makes you win or lose? Okay, a little better than that. That becomes very subjective, but let's make it very concrete. Okay. What makes you win and lose? It's not only how you play, it's also dependent on how others play, right? Yeah? Sorry? Strategy, very good. It's dependent on your strategy and strategy of the other people also, right? Yeah. Teamwork is making the win happen, right? I'm looking at still before that. What influences the outcome? What influences the outcome? It's what you do. It's also what the others do. Like you said, strategies of our team or whatever it is. And opposite team or teams, whoever it is. So if you're looking at a business, then you have so many players in the market, right? You have a shop which is selling mobile phones. How many people who are selling mobile phones? So how do you make a profit? So you have a lot of players in this entire scenario. So how it influences what it does for your business? I mean, this is a very, very broad overview of what I'm trying to tell you, but so game theory is where you try to understand the outcome of a participant's choice of action depends very critically on the actions of the other participants also. So that is where you have a lot of understanding to do. I have a video. So where is game theory very extensively used? One of the examples, like I said, I'm looking at applications rather than teaching you the math required for it. If you understand this, you will automatically develop interest in some basic topics of math. So auction, how many of you have seen the auction happening? It's very nice to watch, right? How many of you have watched? Yeah. Yeah. Yes. Very good. So I'm not a cricket lover, so I don't see these auctions, but I have seen the art and that auctioning that is happening. So can you describe the auction, any of you, very quickly? What happens in the auction? Why is it a part of understanding for game theory? That is the context that I want to bring in. Because this is maths for decision making, and I'm talking about maths as game theory and decision making in an auction. So, quickly, you want to go home soon, you have to speak soon. Teachers also have to go home soon. Quick. What happens in an auction?
They talk about each participant. They keep something for an auction. They have a starting amount.
Absolutely, very good.
And then they start, every participant raise their money, and who's the highest, they win the bid.
That's called as bidding, yeah. So the people bid, right? Whatever it is, what is at stake is not what I'm looking at. There's some element at stake. So auctioning is, that is why we say it is influenced by others, right? There's somebody who says it's 100 rupees, there will be somebody who will say 120, and then it becomes 150. Yes or no? The final bid is actually dependent on what the other people said. Are you all getting what I'm saying? So how this entire scenario influences the entire auction or the cost at which that particular product or whatever is sold. Also, people don't know how much they're going to bid, right? Nobody knows how much is going to bid. So that is again something which influences the entire bidding scenario. So what happens here is you have to understand the scenario, what is being sold, what is being auctioned, and how people are bidding. So a lot of elements. So I'm just giving you some examples of game theory. We also have two things. One is called as collective bargaining. If you haven't heard of it, you'll probably hear later when you do your BCom final or probably even in MCom. So collective bargaining several times is actually used in managing employees and management. So if the employees are disgruntled, in the sense they're unhappy about the pay that they get or the leaves that they get, then they will go on strike or whatever, right? So there will be a discussion with the management, and then something happens and they arrive at a decision or a conclusion. So that is collective bargaining, just a very simple understanding of that. The other is also negotiations between different organizations. Like if you are selling something, there is always going to be a negotiation. Let's say you are selling something at 100,000 rupees, and the person will come back and say, no, I am not ready to give you so much, right? Give me discount. You also bargain, right? For simple 1 kg tomato, you sit and bargain, right? Yes or no? Give me 1 rupee less, 2 rupee less. So that's negotiation. And how, in very simple terms, how does that get influenced is also dependent on how much cheap this guy was selling to the other people, right? If it is end of the day, because he wants to empty his cart and go home soon, he will give it to you at real reduced prices. Have you all not seen that? He will say, I want to bring my cart and go. You take, if there's just 1.5 kgs remaining, he'll give you 1 kg worth of, or no, he'll charge you 1 kg, but he'll give you 1.5. Have you not seen that? Yes, no? So it's all a part of that there are a lot of other factors which actually influence this. So negotiations and collective bargaining. Also about introducing new products into the market. Is it viable or not? Should I put this? So let's say there is some restaurant selling dosas, and all of a sudden they want to make some new variety. I've seen some dosa camps selling 99 varieties of dosas. Have you all not seen that? Not even sure whether it's really selling 99 varieties of dosas. Anybody checked? No? He said, I asked him, he said yes I sell, but I said he couldn't verify, whatever. So what I'm saying is if that person wants to introduce the 100th variety of, there are so many things people should buy, you should be able to make it, isn't it? So a lot of things when you also want to introduce new products. Also pricing decisions. How do people give discounts? Why do they give discounts? On one side you will see Amazon has a sale, on the other side you will see Flipkart also has a sale. Have you had a tough time making decisions whether to go to Amazon or Flipkart? Yes, no? You had, right? So that's actually a strategy. How much to price, what to do. So there's a lot of factors, there's so much of math that gets involved in this. So how we even check what, like for example, when they sell garments, they also see what is the combination, like is the person buying an orange t-shirt with a black trouser or whatever color combination. So their sales, their costing, everything also depends on how people club and make their decisions about buying. So this, all of these things actually fall under a very broad understanding of game theory. I think stock market, I mean, if you're aware of it, very good. What do you know about stocks and shares?
It's like you get to know how much is the Nifty and stuff.
Okay. Yes, sir.
Companies divided among the investors of the product to buy
Okay.
shares.
Okay. You also raised your hand, right? One next to you.
Daily basis, for example, like in MP today is around 17,000 on daily basis, many companies keep on the value.
Okay, so what are those numbers? I'm not going to explain now, but what do you think those numbers are? Again, maths only. So what do you think those numbers are?
Value of shares.
Not really. Anyway, you all heard of the LIC IPO, right? Yes? No? Started at some price and then went on. Yes? So there were a lot of factors which actually influence those things. So what happens in the stock market? How do people trade? What do they do? All of these things are again influenced by. So the last part I want to talk about is forecasting. I'll just take 5 minutes to talk about forecasting. In fact, I had an example also. If you are in for it, then I'll show you one worked example on a sheet, but otherwise you can just skip that. So the last part of math that I want to talk is about forecasting. So what is forecasting? What do you think is forecasting? Predicting. Yeah, predicting. So what I did in the previous season, I sold so many things. Can I sell something in the next season, whatever it is, summer, winter, clothes, garments, and anything that you are looking at. So what makes these forecasts useful, and what is the kind of data that I need to create my forecasting scenario? So what is the time frame? Also, how much do I need to do? What is it that I want to do? And what is the confidence that I have, in this business, that I'm going to really make some money out of this? So we have definitions for confidence intervals. I'm sure your math teachers will teach you that when they do your probability and statistics. So we have a 95% confidence interval, there's a 90% confidence interval, and so on and so forth. So you have these. Was this an okay session? It was a very hurried thing that I had to do, and forgive me for not knowing that you didn't know probability and statistics. So did you get something in this session? Yes, no? No, very hungry or very tired or waiting for the school bus to start, or yes, no, something? Tomorrow if we ask what is game theory, you will be able to give some examples at least, right? Yes or no? Very good. So I'll just wait for this thing to boot up. So just a very simple example of forecasting. So we have some data that's already available. So some numbers are plugged in, okay? From whatever, January 2016 to December 2016, then I want to see what happens in Jan 2017 onwards. So Excel has a whole lot of formulae which you can very easily do forecasting, okay? So like I said, it is the linear curve. So what has happened here is this blue line that you can see. So if you are looking at the numbers, you see up to September 2016 it was increasing, and then beyond that it has actually dropped and it has remained whatever it is. It's 11, 11, 11. So if you just see the plot here, the blue with the dotted lines that you can see, the markers you can see, right? So that is the previous state, okay? And you can do a forecasting. You can use formula that is already present. I'll click on this so you will be able to see the formula, and you can't see it there at the bottom. I'll explain what it is. So you can see now what has happened is all the values in the sales column that has got selected, right? You can see that orange in color corresponding to whatever is there in the pink colored thing. So that's how the data is. So it has taken this particular data and then it has done a prediction. So if you see here, so January 2017 onwards, the ones in green color, that is the prediction that has been done. So there's a formula which helps us to do that. So that is called as a forecasting formula. It's already there, it's programmed in Excel. So you take these values, it will give you what is the forecast. So what happens in the next few months. And you can also get the equation to that particular straight line. Like I said, it is very simple. Y is equal to mx plus c. You don't have to struggle. It will just do everything for you. There is an option here. I think it's too small to see. Okay. So there is an option where you can ask it to fit a linear regression line or a multiple variable regression. You want whatever you want. Exponential. Anything that you want, you can ask it to fit, and it will actually fit and give you that particular line. So this is a very simple example of time series and forecasting. Simple mathematics where it is a y equal to mx plus c. You look at the history of what has happened in the company and then you try to see what may happen in the future. So three different concepts of mathematics. One was with risk, certainty and uncertainty. You remember we looked at a cloth shop being opened. The other was game theory where you have multiple parameters influencing the decision making. Very good for mathematics, whoever is interested. The last part that we saw was a time series forecasting where you have some information about the past when you are trying to predict the future. So I think I'll just stop here. Any questions, if at all, we will take, or we end this session. That's okay. Moral is I should have asked what they know.
Fine, ma'am. I think there is enough time to accumulate that.
No, I could have done another example.
They have discouraged background.
So it's okay, I think so.
Around 10 to 15% of them understand mathematics.
Yeah.
Others are run away from mathematics.
Alright. Okay, thanks ladies and gentlemen. We hope you had a very okay kind of a late evening session that tomorrow you will remember something happened the previous day from 3:30 to 4:30 or 4:45, whatever it is.